now discuss problem number 3. So magsasample problems tayo agad to discuss the analysis of T-beams. So sir, paano po natin kinukuha yung ultimate moment capacity ng T-beams natin? So for that, let us consider problem number 3. So determine the ultimate moment capacity. So since nandun yung word na ultimate, we are tasked to find yung subscript natin na U, which is yung MU natin, of the T-beam shown in the figure. We have F'(C) na 21 megapascal, the value of your F1 na 414 megapascal, and you have 3 pieces of 28 diameter bars located on our bottom part of your T-beam. So we're going to use NSCP 2015. So yung unang part lagi sa analysis ng T-beam natin is we need to find the value of your base of the flange. Pero since given dito sa figure natin yung base ng flange natin, we will skip that part. So for the next part, so mangyayari is we will going to check if true T-beam. Sir, ano po yung ibig sabihin ng statement na yan? So, check natin kung true T-beam ba yung T-beam natin or hindi. In what way? So, nagkakaroon lang tayo ng problema dun sa compression side natin. Kasi nga, meron tayong compressive force dun. So, for that principle, yung nangyari kasi is, meron tayong compression, meron tayong sa tension. Sa tension, wala tayong problema. Kasi it will happen, yung tension force natin or tensile force natin, it will act on the center of your reinforcement. So meaning to say, wala tayong problema kasi eto lang naman yung center ng reinforcement natin. So this will be your D. So it is acting on the center of your reinforcement. Nagkakaroon lang tayo ng problema dun sa value ng C natin or for the compressive force. Bakit sir? Kasi hindi natin alam kung yung compressive force ba natin is hanggang dito lang, hanggang thickness ng flange natin, or less than the thickness of your flange, or lalagpas siya sa thickness ng flange natin. So kung lalagpas yung value ng compression force natin o compressive force natin to the thickness of your slab, therefore, true T-beam yung analysis natin dito sa problem na to. So with that, we will going to check kung true T-beam ba to. So we will going to assume na yung height ng compression block natin is hanggang dun sa thickness ng flange natin. So for the next part, so we're going to assume that the height of your compression block that is equal to the thickness of your flange. So yung height ng compression block natin, that is A. So that is equal to the thickness of your flange or yung thickness ng slab natin. So for that, so mangyayari niyan is we will going to calculate for the value of your compressive force at flange. So for this, we have 0.85 F'(C) multiplied by the area of your flange in compression. So nilagay lang natin siya ng subscript na F kasi nga kukunin natin yung compressive force dun sa flange natin. Kaya F stands for flange. So we have 0.85 F'(C). So yung A natin dito, that will be, so yung area natin, that will become 50 multiplied by 800. O yung thickness ng flange natin, multiplied by the base of the flange. So we have the compressive force at the flange na 0.85 multiplied by F'(C) na 21, multiplied by the thickness of your flange na 50 multiplied by the base of the flange na given na 800. So you have a compressive force at flange which is equal to 714 kilonewton. So sir, paano po nangyayari yung compressive force ng flange na yan? So yung ina-assume natin dito that your compressive force o yung height ng compression block natin is ganito siya niyan. So kung anuhin natin yung stress block natin, so mangyayari yung compressive force natin, which is yung height ng compression block natin, is equal siya dun sa thickness ng flange natin. So meaning to say, yung resultant ng C natin, eto yan. So, mangyayari niyan is, yung compressive force natin, etong buong yan. Okay. So, with that, eto na ngayon yung ano natin, we assume na yung thickness ng flange natin, that is the height of your compression block. Nakuha na natin yung compressive force natin sa flange. Hanapin naman natin yung tension naman, or the tensile force. So, let's assume tension still will yield. So, kapag nag-yield yung bakal natin, the value of your Fs, that is equal to the value of your Fy. So, T, yung formula natin, As, Fs. Tama? Kaso nga lang, nag-yield daw yung bakal, in-assume natin, so that is As, Fy. So, we have tatlong piraso ng 28 mm diameter bar multiplied by yung Fy natin na 414. So, the value of your tensile force, that is equal to 764.76 kN. So, sir, bakit po natin kinompute yung tensile force natin? Di ba by principle natin, kung titingnan natin itong load diagram natin na to, dapat summation forces horizontal, positive. So, dapat yung compression natin is equal siya dun sa tension. So, kung titingnan natin yung tension natin, agad nating makukuha yung force niya. Kasi nga, it will act lang dun sa center ng reinforcement natin. Nagkakaroon lang tayo ng problema dito sa compressive force natin sa T-beams. Sa T-beams lang to. Kasi hindi tayo sure kung lalagpas ba dun sa thickness ng flange natin, yung A natin, or magle-less than siya dun sa thickness ng flange natin. So for that, we will going to compare yung CF natin at saka yung T natin. So we will going to compare CF at saka yung T natin. So yung CF natin, yung value niya is 714 kN. On the other hand, yung T mo naman, that is 764.76 kN. So di ba, by principle, dapat mag-balance or parehas yung value ng compression dun sa tension natin. So kung titingnan natin, nangyari is yung CF natin less than yung value niya dun sa tensile force natin. So meaning to say, kailangan natin dagdagan yung value ng A natin para ma-increase natin yung value ni C. So para mag-equate yung dalawa, kailangan nating ma-increase yung value ni CF. Diba? Hanggang sa marating niya yung value na 764.76 kN. So sir, paano po natin i-increase yung value ng compressive force? So again, C is equals to 0.85 F prime C multiplied by AC. So for that to happen, kailangan nating i-increase yung area niya. So meaning to say, since the value of your CF is, sabihin natin, since yung tensile force natin, that is greater than to the value of your CF, meaning to say, true T-beam tayo. So, kailangan natin i-increase yung area para mag-equate yung compression at saka tension. Meaning to say, mali yung analysis natin dito. Hindi dito yung location ng A natin or the height of your compression block. So, yung height ng compression block natin is lagpas siya dun sa thickness ng flange natin. So, let's say hanggang dito na siya. Sabihin natin na hanggang dito na yung thickness, yung height ng compression block natin. So, if we were going to reflect that, dun sa ano natin, dun sa figure, dun sa T-beam natin, eto yan. So, meaning to say, this will be yung ano natin, compressive force natin. So, lumagpas na siya dun sa thickness ng flange natin or dun sa thickness ng slab natin. So, meaning to say, yung value ng A natin, kung i-compare natin siya dun sa thickness ng flange natin, the value of your A is greater than the thickness of the flange. So, meron tayong true T-beam. Okay? So, we are under case 2. If A is less than to the value ng TF natin, ano naman tayo? Under naman tayo sa case 1. So later discuss natin yung case 1 natin. So for this one, under tayo sa case 2. So ngayon, since alam na natin na true T-beam tayo, kapag sinabi natin true T-beam, ayan, meron tayong T-beam. So T-shape siya. So meron na tayong true T-beam. So we can now proceed dun sa next step natin. So sir, paano po yung next step? So same ano lang tayo dito ha. Same principle lang tayo sa singly reinforced beam, sa doubly reinforced beam. For the next step, we will going to equate yung compression is equals to tension. Assume, since singly reinforced beam tayo, tension still will yield. So for this one, since true T-beam tayo, irregular yung section natin, hindi siya rectangular section. So we have 0.85 F prime C multiplied by the area of compression is equals to AS Fy. So naging Fy yan kasi nga nag-yield yung bakal natin. So sir, ano po yung area ng compression natin dito or the compressive area? So eto ngayon yan. Since yung area ng compression natin is a T-beam, so ganito yung approach natin for irregular section. So for that one, hanapin natin yung value ng A sub C natin. So you have 0.85. The value of your F prime C na 21 megapascal, AC is equals to, meron tayong tatlong piraso ng 28 mm diameter na bar multiplied by the Fy na 414. So the value of your AC is now equal to 42,843.33 mm squared. So ngayon, yung goal natin, kapag nagko-compression is equals to tension tayo, is to find the value of your height of your compression block. So sir, paano po natin gagawin yon? Okay? So for that to happen, gagawin natin is, yung AC natin, kunin natin yung formula. So that is equivalent to, since eto yung AC natin, di ba? Etong shaded region, that is your AC. So pag-add natin ngayon, so eto yung sa flange natin. So meron tayong area dyan na yung base of the flange na 800 multiplied by yung thickness ng flange natin na 50 plus yung area natin na naiwan dito. So yung area natin dito, so that is equal to yung width niya, which is equal to 250 multiplied by yung height niya. So sir, what will be the height of your shaded region in black? So that will become A yung buo, minus yung thickness ng flange natin na 50. So you will have A minus 50. And with that, equate lang natin yung area natin, total area na 42,843.33. You can now calculate for the value of your A by shift solve, which is equal to 61.38 mm. So nakuha na natin yung value ng height ng compression block natin. So if you were going to check that, yung A natin, talaga greater than naman talaga siya sa value ng thickness of the flange natin, which is equal to 50 mm. So therefore, correct yung answer natin. So after nating ma-compute yung ano natin, yung A natin, let us now proceed in computing for the value of your C. So sir, bakit po natin kukunin yung C? So para ma-check natin kung yung assumption ba natin is correct or not. So for that one, since yung F prime C natin, that is only 21 megapascal. So mangyayari niyan is yung A natin na 61.38, it will just be divided by yung 0.85 natin. Kasi nga, 21 megapascal lang yun, yung limiting value natin is 28 megapascal for NSCP 2015. So the value of your C is now equal to 72.21 millimeter. So after that, proceed tayo sa next step natin na check if assumption is correct. Ano ba yung inassume natin dito? Inassume natin na yung tensile steel natin will yield. So if that will happen, yung Fs natin, that must be greater than to the value of your Fy. So, hanapin muna natin yung value ng f sub s natin. So, f sub s, that is equal to 600. D minus c. Yung d natin, that is 300. Minus yung c natin na nakuha na 72.21 over 72.21. So, the value of your fs is now equal to 1,892.73 megapascal. Wherein, fs is greater than fy. Therefore, assumption, correct. Tension still yields. So next naman, hanapin na natin yung pinapahanap ng problem natin. So hanapin na natin yung value ng ultimate moment capacity natin. So sir, paano po yan? So reduction factor multiplied by the nominal moment. So kapag ano naman dito, so for this one naman, since meron tayong irregular section, mangyayari niyan for your nominal moment. So let us divide yung C natin into two parts. So una, okay. So una is, gawin natin, i-divide natin siya sa dalawa. Okay. So gawin natin siyang C1 plus C2. Sir, paano po yon? Paano mangyayari yon yung pag-divide na yan? So for that, let's say, eto muna. So, yung sa flange muna natin, kapag T-beam lang, kapag true T-beam tayo. So, divide natin siya. So, una is, eto natin, C1 natin. So, gawin natin siyang C1. Next naman, yung susunod naman is dito naman sa area natin na naka-shaded dito. Sabihin naman natin na ito yung tinatawag nating C2. So mean to say, yung C1 natin, yung area na covered sa kanya is etong sa flange natin. Ito namang C2 naman, ito naman yung natira. Okay? So for that one, if we were going to illustrate that, so let us draw. So yung principle lang naman kasi natin dito is either kung i-consider mo yung buong C natin, or if you were going to have C1 at saka C2, parehas lang naman yung makukuha natin. So if you were going to refer dun sa C natin, yung buo yung co-consider natin, you are going to apply Varignon's theorem na nakalagay dun sa module natin. So we will propose another solution dun sa pag-compute sa C natin. So for this one, dun sa flange natin, so meron tayo dito sa flange. So magkakaroon tayo dito ng compressive force. Ito yung compressive force natin na merong 0.85 F prime C na intensity. So yung base of the flange, that is 800 by 500. So next naman yung natira. Ito yan. So, meron tayo dito na width niya na 250. Tapos, yung height niya is 61.38 minus 50. So, for this, meron pa rin tayo dito compressive force na acting sa kanya na 0.85 F prime C yung intensity niya. So, with that, mangyayari niyan is dito sa flange natin, meron tayong C1. Dito naman sa natira natin, meron tayong C2 na tinatawag. So for that, yung C1 at saka C2 natin, it will have yung C natin. So we will just propose another solution, no? Para hindi nyo na kunin, hindi na kayo mag-Varignon's theorem. So yung formula naman natin dito, no, is parehas lang naman. So yung C1 natin, paano natin kukunin yan? That is 0.85 F prime C multiplied by the area of your flange. So C1, you have 0.85. So you have 0.85 multiplied by yung F prime C natin, which is equal to 21, multiplied by the area of your flange, which is equal to 800 by 50. Your C1 is now equal to 714 kilonewton. So, yung C2 naman natin, paano naman yan? So, same principle lang. So, yung 0.85 F prime C area nung compression natin. So, i-consider natin dito etong region na to. So, you will have 0.85 F prime C natin, that is 21. Yung area natin dito, meron tayong width na 250. Yung height niya, that will become 61.38 minus 5. So, yung value ng C2 natin, that is equivalent to 50,783.25. Okay. So, for this one, kunin natin yung nominal moment natin. So, unahin muna natin si C1. So, moment tayo dito sa T natin. Okay? So, moment tayo sa T, mangyayari nga is you will have summation moment. So, lagi tayo nagmo-moment sa tension na lang, no? To play it safe. So, meron tayo ditong nominal moment. So, mangyayari niyan is, let's say na yung clockwise is positive. So, you have Mn, nominal moment, minus, dito tayo magmo-moment. So, meron tayo ditong C1 multiplied by the moment arm. So, what will be your moment arm? So, from this, meron tayong D minus yung thickness ng flange natin divided by 2. Minus, eto namang C2 natin. So, we have yung force natin na C2 multiplied by the moment arm. So, ano yung moment arm natin? So, etong buo, that is D minus etong thickness ng flange natin minus eto, yung A minus 50 divided by 2. So, if we were going to equals to 0, so kung aayusin natin yan, yung nominal moment natin, that would become, so yung C1 natin, meron tayong value na na-compute natin kanina, which is equal to 714. So, gawin natin siyang Newton, multiplied by the moment arm. So, yung D natin, that is 300, minus yung thickness ng flange natin na 50 over 2. Plus, kasi itatranspose natin yung C2 natin. So, you will have 50,783.25 Newton multiplied by the moment arm. Yung D natin, 300, thickness of the flange 50, minus yung A minus 50 natin divided by 2. So, you will have a value of your nominal moment which is equal to 208.76 kilonewton meter. So, in computing for your ultimate moment capacity, that is rho Mn. So, what is the value of your rho? Titingnan natin na yung Fs natin. Fs is greater than 1,000. So, therefore, rho is equals to 0.90. So, tension control tayo. So, mu is equals to 0.90 multiplied by the nominal moment. So, you have a value of your ultimate moment capacity, which is equal to 187.88 kilonewton meter. So, this will become your answer. Again, dito naman, pwede nyo i-consider yung buong C na lang natin and then mag-Varignon's theorem na lang kayo. Kaso para sa akin, parang hassle yung Varignon's theorem. Kaya ginawa ko na lang is portion by portion na lang. So, if you want to have alternate solution dito sa problem natin, see yung solution natin dun sa module natin.